All right, so we are going to talk about exponential functions. So the exponential function f with base b is defined by f of x is equal to b to the x, or remember f of x is the same thing as y is equal to b to the x, where b is a positive constant other than 1, because if we raise 1 to any power, it's still going to be 1. So it's not going to be an exponential function because it's not going to grow or decrease. And that's where b is greater than 0, b cannot equal to 1. And x is any real number, so it needs to be positive and it needs to be something other than 1. So some examples of exponential functions are f of x equals 2 to the x, g of x equals 10 to the x, and notice that the base of these is going to be 2. Here the base is 10. H of x equals 3 to the x plus 1, the base is 3. J of x is equal to 1/2 x to the minus 1, so the base is the 1/2 here. So it's still greater than 0, but it's not equal to 1 on any of those. So each function has a constant base and a variable exponent. By contrast, the following functions are not exponential functions. So f of x is equal to x squared. G of x equals 1 to the x. So exponential functions means the variable is in the exponent. So this has got the variable as the base. 1 is not an exponential function, so not that one. H of x equals negative 1 to the x, not because it is a negative value. And h of x equals x to the x, not going to happen either because the variable is both the base and the exponent. So there's some explanations on those. So here is what a graph of f of x equals 2 to the x looks like. It's going to grow exponentially. If it is g of x equals 1/2 x, you notice that it kind of actually decreases. And both of these head towards what we've talked in the past about the asymptotes equaling to 0. So there are some characteristics of exponential functions of the form f of x equals b to the x. You've got your domain consists of all real numbers, so in negative infinity to infinity. The range of all positive real numbers, so it's from 0, it does not include 0 because it actually won't reach 0 because of the asymptote, going up to infinity. The graphs of all exponential functions in this form pass through the point 0, 1, so on each of the graphs you'll notice that the y-intercept of 0, 1 is where the functions will always pass through. And that's because anything to the 0 power is equal to 1. So that's why it's always going to hit that. The y-intercept basically is going to be 1. There is not going to be an x-intercept because there's an asymptote of y equals 0 there, that horizontal asymptote, and so it's never going to get down there. So there will not be an x-intercept. If b is greater than 1, the graph is going to go up to the right in an increasing function. If it is a fraction, between 0 and 1, it's going to go down to the right, and it's a decreasing function. And the smaller the value, the steeper the decrease will go. And if the greater the value, the steeper the increase will go. So, let's see. If it is a one-to-one function and it has an inverse, that is a function. And the graph approaches but does not touch the x-axis because of that horizontal asymptote. So here you can see both graphs together. This is where b is greater than 1, so it's increasing. This is where b is between 0 and 1, and so it's a decreasing function. Here's our horizontal asymptote, and they both cross at the point of 1. We also have the natural base e. So f of x is equal to e to the x is the natural exponential function. E is between 2 and 3, the value of it, because we find that 2 squared is equal to 4, 3 squared equals 9, but e squared equals 7.389. So that tells us it's between the values of 4 and 9 when it is squared, so therefore e is between 2 and 3. Here we have e to the negative 0.75, and that's going to be equal to that. So as you raise e, you're going to have different values of it, just like you would any other number. With compound interest, is interest computed on your original investment as well as on any accumulated interest. So the formula is right here. A is equal to P times 1 plus R over N to the NT. But P is going to be your principal, R is your rate, N is the number of compounding periods per year, and T is the time length of the investment. The accumulated value is the value of the money. That's the A part. That accumulates over time. So this one is when we have compounding periods, we use this formula. If you don't, and it's continuous compounding, then we use E. So you've got two formulas that you'll need to know. Here I have listed the number of compounding periods per year. If it's annually, it happens once a year. Semi-annually is like a semi-truck, a semicircle, so it's 2 times. Those have 2 parts. We're talking about 2. Quarterly, there are 4 quarters in a dollar. There's 4 quarters in a football game. So quarterly is 4. Monthly, there are 12 months in a year. And weekly, there are 52 weeks in a year. All right, so let's go look at our first example. For example 1, if you invest $8,000 for 6 years, choose which account is better, 7% compounded monthly or 6.85% compounded continuously. Remember, if it's monthly, that's an N, that's the number of times it happens, you're going to use the first formula. If it's continuously, you're going to use E. So let's go figure out what our 2 options get us as far as the account so we can figure out which investment is better. So on this first one, we are looking to find with 7%, 8,000 for 6 years. So, and it's monthly. So we know that our formula is A is equal to P times 1 plus R over N raised to the NT. So we need to know what our letters mean. So let's look at our problem and see what we can find out. So we're investing $8,000. That's the amount that we're putting in. That's the sum of money invested or borrowed. That's our P for $8,000. For 6 years, that is our T. For 7%, that's going to go right here, but we have to change it to a decimal always. And compounded monthly, well, monthly tells us it's 12 times a year. So we're looking for the accumulated value here. So A will be equal to 8,000 times 1 plus 0.07 divided by N, which is 12, raised to the 12 times 6. Now you can put this all in your calculator. You need to be careful about this part, whether or not when you raise yours to the calculator, does it give you a square or do you need to put parentheses around the whole thing? You really need to practice this with a calculator so that you know how to put it in. If you're taking a test in my class, the setup will be most of the points. The final answer will be 1. The other thing you need to know is that when we're dealing with money, we always round to 2 decimal places because we stop at the cents. So this will find that we have 12,160.84. So this is option 1. We also need to look at the second option. The second option was 6.85% compounded continuously. So here we have A is equal to PE to the RT. So we again need to know what we're looking for. So our A, we're still looking for that. P is 8,000. R, our rate is 6.85%. We need to make sure we change that to a decimal by moving the decimal over 2 places to the left. And compounded continuously tells us we don't have an N, but we do have the T, which is also still for 6 years. Because we're trying to figure out which account should we choose for the same amount of time. So A is equal to 8,000 E to the 0.0685 times 6. And you're going to find that you have the E key is on your calculator. And when you push the E, you will actually have a box that should open, or it'll raise it up. And again, if you need to, use parentheses. When you put this in the calculator, you should get 12,066.60. So again, you need to practice those. So the question is, which one is better? Well, this one we made 12,160. This one made 12,066. So which option is better? Well, our A option is the better choice because we made more money. Same amount of time. It will not always be that way. It depends on the interest rates, and it depends on how much you're putting in, the time, all of that will change. All right, example 2, it says if you invest $10,000 at an annual rate of 8% for 5 years, choose which account is better, compounded quarterly or continuously. So we're investing $10,000 an annual rate. So annual tells us that our at 8% for 5 years. So, there we go. Choose which account is better. Compounded quarterly, that's what was changing, or is it continuously? So do we have an N or not? All right, so let's work on this one. So this will be example 2. And we're looking again at 2 options. So the first one we'll look at is A is equal to P times 1 plus R over N raised to the NT. So let's list all of our variables. So we don't know what the A is. That's what we're trying to find. Our principal is 10,000. Our rate is 8%. For 5 years, that's our T, and it's quarterly. That's going to be 4. So A is equal to 10,000 times 1 plus 0.08 divided by N, which is 4, raised to the N times the T. When you put this into your calculator, you should get 14,859.47. And now we need to do the second option, continuously. So that's going to be A is equal to PE to the RT. So again, we need to figure out what our variables are. So the variables we have are A, P, R, and T. E is never a variable because it actually has a value in your calculator. So our P is still 10,000. Our R is still 8%, which is 0.08, and our T is still 5. We just don't have the N. So A is equal to 10,000 times E. Sorry about that. So A is equal to 10,000. We don't need a parenthesis for this. E. 1, 2, 3, 4. And we have too many zeros. All right, so we'll cross that one out. So 10,000 E to the 0.08 times 5. So 10,000, make sure you pay attention to your zeros. And E to the 0.08 times 5. And when you put that in the calculator, you will get 14,918.25. All right, so in this case, which option is better? We have 14,859 and 14,918. This will be our best option. So this time, it was better to go with the continuously.